Good evening, everybody. Thank you for having me this evening to share my hobby with every one of you. And the previous presentation was so interesting that I was imagining, like, would Betelgeuse still in the sky in 6,000 years or 13,000 years later? Or would Elon Musk just put all the satellites in the sky and make just mess up all the constellations? It's always interesting to look at the sky. As a kid, I always wanted to look at star. I think I shared before in my last presentation that my first object that I looked through was Saturn through a 3-inch telescope, and it just blew my mind, and it totally changed my way to look at the sky. And I grew up in Hong Kong, and it was a big city, and there's actually no star in the sky except bright planets. And when I and my family decided to come to Canada in the early 90s, when I was a teenager, I realized the sky is actually dark. I can see lots of stars, even though I was living in North York, but I could see stars and stars in the sky. And so fast forward, many years later, when my kids were a little bit older, I still love observing, observing the sky as an amateur observer, but I started taking pictures in 2016. So that was my hobby since then, and I just love challenging myself in taking pictures of using different types of equipments. So the topic tonight, I would like to share with you how I use a Dobsonian telescope to take pictures, especially take pictures of an artificial, satellite or ISS. Okay, so I will show you how what challenges that I had to overcome to take some of the pictures. So when I started this hobby about 8 years ago, I got into different types of photography, like wide field, deep sky object, planetary, and solar photography. When I look at this solar photography picture, the first thing in my mind, in 3 months and 5 days, our moon will be covering this star, and that will be spectacular. So I already make plans for that day. I don't know about you, but it is going to be once in a lifetime opportunity. I saw the last eclipse in 2017. And it was amazing. So this time, hopefully, we get good sky, and we can actually witness the solar eclipse in this year in April 8th, but not in Toronto. So I think the closest place will be somewhere east along Lake Ontario, near Kingston, or Prince Edward County, yes. It was right in the middle of the path. So, Dobsonian. So, before that, just quickly talk about, if you want to do wide field astrophotography, you probably just need a tripod, or if you can have an equatorial mount or an azimuth mount. So that is the kind of mount that just go horizontally and vertically, or an equatorial mount that can actually track the star. But basically, a tripod can do picture like that. It's very easy. And if you want to do some deep sky object astrophotography, you would like to have an equatorial mount. Sometimes the alt-az mount may work, but not as good as the equatorial mount, because deep sky objects, usually they're smaller. You need a very good tracking on it, and without any what we call the field rotation that the alt-az mount will provide. Planetary astrophotography, you need a long focal length telescope and a very sensitive camera. For solar imaging, of course you need a solar filter. You cannot just take the picture of the sun without any solar filter. That would damage your equipment, and that may damage your eye as well if you look directly through a telescope without any protection. And Dobsonian telescope is actually a Newtonian telescope. But this telescope is actually more popularized by John Dobson in 1965. And the design is very simple, Newtonian reflector on a very stable platform. And usually we say that Dobsonian telescope has a very good aperture to cost ratio, because if you actually shop around different telescope, of course, the bigger, the more expensive. But the Dobsonian telescope actually has the very good aperture to cost ratio because of the simple design. And relatively, if you pay the same amount of money, you will get a larger aperture, a larger diameter, a larger size of the scope. So for observation, it is great, it is amazing. 8-inch Dobsonian telescope without tracking mount, it is relatively more affordable than an 8-inch refractor, for sure, or 8-inch, other type of design telescope. Dobsonian is very economically possible for many, many beginners as well. And, sometimes when I interact with people, what is the best, first telescope you could buy for teenagers or for new astronomers? I would suggest a tracking or go-to Dobsonian telescope because it is actually a very easy device to use for any beginners to first of all, know about the sky, but also they can actually select, the mini computer there, and it will just lure to the right direction and find the right target. So it is a very, very handy feature. My Dobsonian telescope I got about 2 years ago. It was on sale, big sale. I don't know why they were on sale. I was just taking a chance, but yeah, it was a big sale. It was a 14-inch tracking Dobsonian telescope. I regret it a little bit after I got it. After I saw the box shipped from the supplier to my house, the box was huge because this telescope actually is about 150 pounds in total. The base is 94 pounds. The OTA, the tube itself is 53 pounds. The total is about 150 pounds. And I couldn't fit this into my vehicle as well. Not even the trunk, not even the back seat. I can only use it in my backyard because it is just humongous. So, so far I haven't taken this telescope away from my backyard, but how did I move it around? Many people ask. Doggy from Canadian Tire with some bungee cords that can, yeah, I can move it around in and out of the shed in my backyard. So right now it's been cloudy for the last many months and it's just sitting in the shed without doing anything. And on top of observing, I use my Dobsonian telescope to take pictures of planets, which I will show us some of the samples at the end of my presentation. But I want to show you today about this very interesting possibility using a Dobsonian telescope is to take pictures of ISS, International Space Station. My photos are not that great, relatively, but I was so happy that I got some decent photo and I can show you my progress from my first trial last year and then less than 2 years ago and then up to this point what I have got so far. This is my latest ISS photo. It is not the clearest, but I'm so proud of myself to get one of these after 12 attempts this year. And so you can see the solar panel here, and there are different names of the parts, and these are the solar panels as well. Well, the challenge of taking ISS is that that it is orbiting around us every 90 minutes, and it is moving pretty fast in the sky. So, ISS is moving, and if you remember the movie Gravity, George Clooney was setting up the stopwatch for 90 minutes because everything at that altitude above the ground has the same orbital period for around 90 minutes. And ISS also has a similar orbital period, about 90 minutes. It goes around the Earth every 90 minutes. And the size is about the size of an American football field, about 100 meters length and 73 meters width. For imaging, I think what I found is that the higher the maximum altitude, that is what angle, imagine the ISS is actually moving across the sky like that. What is the angle above the ground at the maximum altitude? The higher above the ground, the better it should be. Because if the ISS is low in the sky, there is a much thicker atmosphere between you and the space station. So when it is much higher up in the sky, the amount of atmosphere is actually much shorter. And you could actually get a better, clear picture, and also it is actually closer to you. It's actually closer to you. So to get some details, you want ISS be closer to you and also with less atmosphere as possible. I didn't know about this, but I was preparing this presentation. I kind of searched up more information about the ISS. And because of the orbital inclination of 51.6 degrees, if you live beyond 51 degrees north or south of the equator, ISS will never appear directly above your head. Good that we are at about 45 degrees altitude. So sometimes, yes, especially in May, June, ISS could be way above your head when it passes. So that would be a good thing. How do we know when ISS be available, be observed, to just observe or for taking some pictures? Heavensabove.com is a very good website for you to check out. There's a desktop version, or you can actually download on the mobile app. Astrophotography.com is also one of my favorite apps to check the weather forecast, and also it gives you the upcoming notice about when ISS will be available for observation or for taking picture in the sky. Here's a screenshot for heavensabove.com, and the next ISS pass through, I think is the good one, is actually January 3rd. Oh, actually, tonight. Oh, it's already passed. Okay. Yeah, so yeah, you can see the highest point, the altitude of it. And so if you actually go to the web link, you just click on this one of these dates, and you have the whole map showing to you where and when ISS is observable during that time. And you'll find that most of the time is actually early in the morning for a reason. Okay, so of course we cannot observe ISS during the day, but in order to see ISS, the space station must be reflecting the light from the sun without getting into the shadow of the Earth. So we rarely see ISS near midnight because, around the midnight time, the Earth shadow will be, right above your head. And when any satellites, just pass through the Earth shadow, it won't reflect any light for you to see. So it will be shortly after sunset or shortly before sunrise. This is another app that I always have on my phone, astrospheric.com. And you see that when you see this little icon here, you can actually click on it, and you'll see the map and the time when ISS is available in the sky. So the challenge of taking picture of ISS, first of all, and the biggest challenge, is that it is a moving target. It is like, how would you take a picture of a moving race car? Of course, it's not as fast as a race car. I have a video to show you how fast it actually moves across the sky. But there are many other uncertainties, and I had to really test run it and try different things and take your own notes and then come up with my own strategies. There is uncertainty in exposure time and the shutter speed. I found that at different altitude of ISS, the brightness changes so much. So if you want to take a good picture when it is a higher altitude in the sky, you have to kind of estimate like what is the best exposure and the shutter speed for that moment. Of course, I screw up so many times, but I have my own number. I can share that with you in a second. The field of view is extremely small. The field of view I'm talking about is how much space in the sky the camera and my and my telescope combination is actually capturing in the sky, not the size of the ISS. So if you look at, if you stretch your hand, if you look at your pinky, that's about 1 degree. And the full moon is half a degree. So if you stretch your hand, you look at your pinky, the size of the full moon is probably around half the width of your pinky. And the field of view of my camera and the telescope setup is about 1/3 of the size of the full moon. It's extremely, extremely small. And the size of the angular size of the space station is about 63 arcsecond on average. It is 1/30th of the size of the full moon. And it is moving. It is moving in the sky. So can we track on it using computerized program, using software? Yes. And I'll share that with you in a second. But there's a problem with my setup that I couldn't use any software to track it. And also the sky condition is another big factor. This is what we call the seeing condition. It is very critical for planetary imaging and also especially for ISS. But for ISS, it is actually a lucky game. Like if you can track it well, you still have the luck to get a good seeing condition for that critical seconds if you want to get some good pictures. And I live in Stouffville, which is close enough to Toronto. The sky is actually pretty bad, and the atmospheric turbulence is really, really bad. So that's why I have to keep trying and trying until a moment that it is good seeing, and then for the few seconds I get some good captures and I can get some good pictures. So let me share with you what equipments that I'm using currently for my ISS pictures. I use the mono camera Player One Apollo M Max. The size of the pixel is about 9 micrometer. It is a camera with pretty big pixel size, relatively, but it has a really very sensitive sensor, so the frame rate is actually pretty good. I've tried different cameras before. I had a Mars C, which is a color camera, and a Mars M, a mono camera, but so far I've tried different settings and different cameras. The best result is using Apollo M Max with actually a 3 times Barlow, which is like a 3 times the focal length of my telescope. And you need a camera with a high frame rate because again, it is a lucky game. And you need a high frame rate. Hopefully, if you get a couple of frames that are good, then you're all set. You can go into processing and you can try to sharpen it and so forth. Also, I need a 3x Barlow. Barlow is basically a focal extender. So the focal length for my telescope is 1,650 millimeter, 1650. So with this Barlow, it would make them times 3. So basically, we are talking about 4,000-ish focal length with that camera, because I need that, because the ISS, the angular size is actually very, very small. So here's a telescope, some of the specs. I have the focal length here. And can we track it by the mechanical motors there? Yes or no? But I found that there's no room for error. That's why I had to track it by hand. And I'll explain to you why in a moment. And so you can see the field of view using astronomy.tool, the website. You can see the field of view is actually 1/3 of the diameter of the moon. The moon is about half a degree. This is 0.137 times 0.12 degrees. So, and ISS angular size is even smaller than that. And so I mentioned that already, the pinky, if you stretch your arm, that's about 1 degree. So imagine you divide from east horizon to the west horizon into 180 degrees. So if you divide this by 180 parts, 1 degree would be the size of your pinky when you stretch out your arm, and the moon is about half of that. And you can see the size of the view is extremely, extremely small. Software that I use Fire Capture, which is a great planetary and ISS capturing software. It is totally free, and I like Fire Capture for planetary imaging because it has a very unique function, which is auto-align, this button here. So sometimes the tracking is off a little bit, but if you actually select the right ROI, the region of interest, you can digitally center the target dead at the center with some room for errors in tracking. So you can actually save a lot of time for processing for planetary imagings. But I'm not talking about planetary imagings today, but I'm just sharing with you, this is the software I use to capture my picture. Now, so how fast does it move in the sky? Here's my telescope. I was hand tracking on it. Now you see that there's a dot above the tree. Now it's more visible. That's ISS. That's the International Space Station. So this is in real time. You can see the timer. It is in real time, and that's how fast it is actually moving across the sky. So from the time it is visible until it's got hidden by a house, my neighbor's house, it's about a minute time. So you see the ISS is moving in the sky. I was trying to track on it, trying to put it at the center of the frame of my setup, and yeah, sometimes it will disappear in the middle of the sky as it goes into the shadow of the Earth, but sometimes you can see that for like most part in the sky before getting into the shadow. Right? So now is above, almost at the highest point in the sky. So manual tracking is my strategy, and I learned from failure. Just like anybody who started this hobby, this learning curve is so steep. You have to fail so many times to get something decent. So I learned myself, from the failure experience, from bad alignments, from wrong exposures. Altitude was too low, and I learned that. And dual problem, especially during, sometimes when the temperature is too cold, I found, how come I don't see anything? Oh, because the mirror is actually all fogged up. And I didn't realize that. And I misread information from heaven above sight. That's actually pretty interesting. One night, I think it was just last year, I was looking at heavenabove.com, and I printed out the information, and it predicted that, ISS should be in the sky at around 4 a.m. So I set it up, before I got to bed, and I woke up at 3 o'clock. I tried to get everything set up. I was so excited. The sky was so clear, crystal clear. And I waited. I didn't see a thing. I only see star in the sky. Where was ISS? I thought I misread the date. No, it was the right date. How about the time? Everything was correct. But that was actually, I misread the information where the whole ISS was actually inside the Earth's shadow. And I didn't know that. I have to double check different sources of information to confirm, yeah, it was really in the shadow. So, yeah, I learned from that because I was so excited. I was so ready to send good pictures. It was like 87 degrees up in the sky. The highest point is almost right angle. And in theory, that should be the moment where you can get the closest approach, and the sky was like, the seeing condition was so good. I disappointed, but I enjoyed that, and it was just a learning process. So when I talk about alignment, what I meant was that you have to use the guide scope at that time to line up with the main scope, such that because I was only guiding with the guide scope for the first year, and the problem is the guide scope was left and right, top and bottom flipped, and it was really confusing. Like I know the ISS was going up, going higher and higher in the sky. But when I look at the finder scope, when I move the scope up, it actually went down. And when I move left, it goes to the right. So it was so confusing. And then I search up on internet, okay, what do other people do? And then, okay, I understand now, because they were using a Terret. And the one I chose is the Explore Science Reflex Sight. It is what I use now to track the ISS. So the alignment was this little dot right here. So I recognize this dot, it is the lowest dot at the inner circle. I have to carefully align this dot to a very far target. Make sure that if ISS passes through this dot, it must be captured in the frame. All right, I have full confidence that when ISS is passing through. So imagine my laser dot is the ISS. Sometimes it just passed like that. I know that it's not good. And if I move the scope again, it may just go to the right. Sometimes I see that if ISS is in this path, I can actually now it's passing through this dot. Then I capture that for that split second. So here's my routine, precisely align the finder scope and the turret ahead of time. Everything set up, the focusing has to be dead on, and don't touch it afterward. And make sure there's enough storage space in your laptop. I have an external solid state drive for storage purpose. You need to have at least 50 gigs of data for that night, and set exposure, time gain, and other parameters. And when you see ISS starting coming up from my neighbor's house, then I start tracking on it. And I found that only when ISS is 65 degrees or above the sky, I could get some better than average pictures with the help of good seeings. And my setting here is that, with the 3x Barlow, with my setup and the camera, half a millisecond exposure time, gain 210, and I have about 135 frames per second. How does it actually look like? And I have a short video to show you in a second. I know the time is short now, so let me just quickly go through some of the key events I prepared to show you here. During my first attempt, I took 18,000 frames. For that, a minute and a half or 2 minutes passed by. ISS only appeared in 1% of all the frames. And the funny thing is, I didn't know there's software out there that can help you locate the ISS from all these 18,000 frames. The first time I did it, I spent 5 hours looking at each frame one by one. It was painful. I tell you, again, I learned from mistake, and I thought if there's a problem, there has to be a solution. So go online and ask people, and then now I have the solution. I'll share with you what software that can actually save you hours of time on looking at all the frames. Only 7 frames were useful, but still, that 7 frames will give you some, like my first picture I will show you in a second, is blurry, but I was so excited when I first got the first picture. Second attempt, better. And I have 15% of the overall frames with ISS in there. However, not all the frames are useful. Right? I get relatively more useful frames, but not all the frames are useful. So this is called the leapfrog style guiding technique. It is that when you predict the ISS is coming to your direction, you kind of move it ahead of time, and then let ISS passes through this dot. So I have to move forward, stay, move forward, stay, move forward, stay, and so forth. This is called the leapfrog style guiding. And because of hand tracking, as I said, I spent 4 or 5 hours just looking at the frame. Now I know there's a software called PIPP, which is a free software. It looks something like that. It can actually detect here, object detection, because most of the frames are just pitch black, because ISS wasn't in there. But it can actually scan all your thousands of frames and just take out the frames with ISS in there and crop it and center it for you. That saves you so much time. And here's the first raw video. The seeing was bad, but look, here's the ISS coming closer and closer and closer. That was overexposed, I can tell already. This is overexposed, but you see the solar panel, right? This is from the program that is searched for the ISS pictures, all of these hundreds of thousands of frames, and they just put maybe like 200 frames with ISS in there and put them into like a video. And the second video is slightly better because now I adjust the exposure. It is no longer overexposed, but you can see that at one point it was a little bit clearer than the previous video. Maybe it's around here. It was much clearer. You see the SpaceX capsule is the top black stuff here. Okay, the top white stuff here is the SpaceX, the docking port. And yeah, so the quality is not that good through YouTube, but it was a better capturing moment. So the seeing was okay. So all I need, in summary, for taking ISS picture is just some luck, because I just need a few adjacent frames with good clarity, with good seeing, especially when it is near the highest point in the sky. That's all I need. If I capture ISS low in the sky, it's not useful. After you pass through the highest point low in the sky, it's not useful. Only when it is at the highest point in the sky, it is useful. I only need like 2 seconds of clear sky. That's all I'm asking for. And so if I'm lucky, if I get a few good frames, then I will proceed to processing the pictures, try to stack a few of them together and sharpen it using a freeware IMPPG, and then use Photoshop to clean up the noise and to just sharpen everything. So this is my first attempt. I was so excited to get the first picture, 2022 May, and yeah, so again, there was only 1% of the frame found from 18,000 frames. I think 7 of them were useful, and I got something like that. At least I see some details, and I was happy about it. And second attempt in May 14th, 4:30 a.m. Now you see, it's better, it's better. And at least I see some clarity in the picture. You see that, but it is still overexposed. So I was thinking like, what do other people use? So I try myself and look up internet and what other people do, and I come up with a slightly better picture in May 29, 2022. I can actually identify many of the features of ISS. And then in July 15, my 5th attempt that year, it was great. Like this picture is slightly better. This picture is actually with an altitude of 87 degrees. So it's almost directly above my head. And so that was the ISS picture. This year, May 28th, my 7th attempt, finally got a clear sky, a little bit better altitude. I got this picture. And yeah, you can tell it's actually so much better. No, thank you. And my 12th attempt this year in July 27th, and it was a black and white picture indeed. And I thought, okay, black and white doesn't look realistic, and I use an AI platform to colorize it. And I honestly, I shared that when I shared this picture on social media, I say, this is not the real color. I did not use a color camera, but I used AI to add colors on it. So it looks more natural. And this is the link for the AI platform I used. So if you have any black and white picture, you can actually upload here. It will make it colorized, and it's cool. It's cool. So yeah, that's my 12th attempt this year. And can we track it mechanically? Yes, there are software that can actually do that. So first, this is the Skywatcher mount software for satellite tracking. So it is designed for tracking satellite for any Skywatcher mount. And another software is called the PreviSat. It is another software available out there for free. And Skytrack, I think this one you need to pay a very small amount to have the full function after 2 weeks. But yeah, I tried this and it works. And it works. It works, yes, when I'm observing the satellite just visually using a low power eyepiece. But I found that the satellite is still moving back and forth in the view. How do people track satellite using mechanical software and machines and software? They all use a high-end tracking mount, like very expensive high-end tracking mount. And because I have no room for error, because remember the ISS is so small, the field of view is extremely small, I know that when I can track it visually, I know it doesn't mean that I can capture it using my camera. So I have to give up the software option and track it by hand. I found it that it's more reliable. And so that's why hand tracking is the way I go. If I have more high-end tracking mounts, maybe I can go for the software with photography. Look at this. Compare my picture with this picture. Like, there's no limit how good you can actually take. This is not from me, but this is the best ISS photo I've seen to date on social media. This is by Michael Zuckeran, and he's one of the famous ISS photographers out there. He got like amazing pictures. Look at this detail. I didn't know like that star thing on my picture actually has has features on it. This is amazing. So this is very inspiring to me because they're using similar equipments that I have, but we can only do better and better in this hobby. This is just, in any domain in astrophotography. So with the Dobsonian Telescope, I can take picture of different planets. This is my Jupiter picture. You can see the seeing has been pretty good. This is the actual view on my computer. There's no jumping around because the atmosphere was so steady and it was great. So that's why I got a pretty good picture for Jupiter that day. So I was using my 8-inch Summit Cassegrain for some of the pictures until 2022, upgraded to a Dobsonian. So it was a great journey for taking picture of planets. Also Saturn. This is my latest picture of the Saturn. As the ring is getting closer, the edge is getting closer and closer to us, it may disappear from the view in the next few years. Mars, during the opposition last year, December, it was so close to us, and I took the opportunity to take some good pictures of Mars. The Mount Olympus is right here, the tallest mountain in the solar system, Mount Olympus. And Uranus and Neptune, it is also possible with the clear sky. So that night, I actually took this picture, this one, Mars, and Uranus and Neptune all in the same night. Because the sky was so clear, I didn't want to give up that opportunity. So of course I didn't sleep. And I had to work on the next day too, but whatever. It was a great experience. And so there's some of the specs right here. And what about deep sky object? Yes, Dobsonian is actually possible for taking photos of a deep sky object, but the exposure has to be very short in total, not just the every single exposure. This is 60 times 1 second. That means each exposure is 1 second. I stack 60 of them together, because there's something called field rotation. That means that the field, the view will basically rotate after time, and it won't work if you have a long exposure, unless you have something called a field rotator. It's a mechanical thing that you can actually purchase, and it will derotate the camera for you automatically. M57 Ring Nebula using my Dobsonian. Again, this is 60 times 1 second. It's fun to play with it like that. So it is possible, but not ideal for deep sky photography. And sorry, I overtime for 10 minutes, but thank you so much for your attention. Is there any question about taking pictures using this telescope? Yeah. Thank you. So there's a question right there.
Well, I walked there. I want to say fabulous images and great presentation. Really well done, Benjamin.
Thank you.
Okay.
So you said that you need good photos over 65 degrees, and so not counting bad weather, how many kind of times in a year is it possible over 65 degrees without it being in the moon's shadow?
This year in 2023, I think I had like 13 times. No. If it is above 65 degrees, just a few, less than 5. Because sometimes it's not clear, it's cloudy and everything, right? And there's a question there for that gentleman there, back there, with the red shirt.
Yes, I'm curious about moving and tracking manually, because when I try to do this with my scope, this 8-inch, everything is vibrating.
Yeah.
How can you deal with this in your Dobsonian?
I took a deep breath, hold on to it. I didn't breathe, really, for most part of the tracking. So I took a deep breath, just staring at it, using the alignment, and then just drag it. And I have to like really, really steady. I found that I cannot loosen all my knobs. I have to tighten a little bit, maybe 10%. So some friction can actually eliminate some of the vibrations from my hand. Yes, there's a question here.
What was the shutter speed you used?
Shutter speed is about half a millisecond for some of my pictures, 0.5 milliseconds.
I have two questions. One is, how does the sun, the angle to the sun affect the picture? Because obviously different things might be illuminated. And the other question is, would it be a real challenge or is it impossible to get a picture of the ISS when it's actually in the Earth's shadow?
Now, I don't know. I don't think there's any way to take a picture of ISS when it is in the Earth's shadow because it is not reflecting any sunlight. And to your first question, I can only say that I have seen different like configuration of ISS. Sometimes when the solar panel is directly facing me as an observer, everything will be overexposed. And I found that the best exposure is that when the solar panel is not directly facing us, and maybe at 45 degrees, and my exposure will work. So it's a lot of try and error, I hope there's a like recipe telling us what to do, but I haven't found any. So lots of people doing the ISS photography, they're always trying and error and see like what works the best.
Questions online? Yep. Okay.
Frank Dempsey, comment, great work. Question, tracking a Dob near the zenith is easy or is it the worst position for tracking? Is it easier to track further away from the zenith?
My experience is that it's actually easier. It's actually easier because instead of moving up, before and after the zenith point, you basically just move the scope horizontally, kind of, right? Because the arc is like that, and there's not much motion, in the up-down direction. So to me, it's actually because if you know the path is going to be like an arc, if you can predict that, you can actually move the scope ahead of time and let it pass through the center point of the alignment. So I personally found that it's easier at the zenith point.
Copy that. Okay, that's a great answer. Comment from Rain Lang. Super strategy, process, and diligence. Great that you strongly focus on few goals and achieve so much success in photography. Photographing your treasure, the ISS. Cheers.
Thank you so much.
Any more questions for Benjamin? I have a question myself, actually. Yes. Great planetary images as well, beautiful, and deep sky too. I wanted to ask you about the deep sky images. It was only a 1 second exposure, but your telescope mount was tracking at the time, was it?
Yes, it was tracking.
It was, okay.
It was tracking.
Okay, gotcha. The reason I was asking is I did attempt that with my Dob, which is not motorized, and even 1 second you get a blurred image.
Well, even my tracking Dobsonian, I found that if my exposure is 2 seconds, the star already moved because the tracking is actually not stable.
That's right. Okay. Very good. All right. Thanks again. Great presentation.
Great. Thank
Benjamin.
you. Thank you.
And we'll take a short break while we go to prepare for announcements.